In this lecture, we discuss heat and internal energy. Internal energy, which we use net U, is the total energy associated with the atoms and the molecules within a system. Heat. In this lecture, we use letter Q for heat. It's a transfer of energy between a system and its environment due to a temperature difference. An object doesn't contain heat. Heat is energy in transit. We have a unit for heat. Of course, it's a part of energy, so the SI unit for heat is always joules, but we have a specific unit for heat that we use widely. It's called calories. Now, for this definition, the energy necessary to raise the temperature of 1 gram of water from 14.5 Celsius to 15.5 Celsius degree, that's 1 calorie. And in terms of joules, in joules, 1 calorie is 4.186. I also want to point out that if you look at our food, usually they would tell you how much calorie it contains. And for that is capital calorie. Now this one, this by definition, this actually should be lowercase calorie, but is the first letter, so it's been put capital automatically. And the capital calorie and the calorie is differ by a factor of 1000. So this is 1000 lowercase calorie. So it's 4186 joules. Different metals requires different amount of heat to change their temperature. So we use a quantity called specified heat to describe this relation between for different materials. And so in this equation, Q is the amount of heat added to the matter with mass M, and the temperature change is delta T, and Q divided by M times delta T will give us specified heat. And this table here gives us what's the specific heat for different materials. Of course, we can rewrite this equation as Q equal MC delta T. Now we can have one example. For example, we have half kilogram of water. We want to increase the water temperature by 3 Celsius degree. So the amount of heat we need is mass of water. Specific heat of water, we can read it from here, which is 4186 joules per kilogram per Celsius degree times the temperature range we want, 3 Celsius degree. So it requires about 6.3 thousand joules to increase a half kilogram of water by 3 Celsius degree. Now, if you actually melt the ice and you observe during the melting phase, the temperature of ice wouldn't change. So the ice melting to water, we call it a phase change. So it change from the ice phase to liquid phase, solid phase to liquid phase. And the same is the water boiling into steams, gas. There's also a phase change from liquid to gas. And in that phase changing, adding heat does not change the temperature of the matter. It's just a change from one phase to another. And this energy is called latent heat. So the formula we use, the heat we add into the material, and this is, look at the unit for latent heat is joules per kilogram. So we should use mass of the object, mass of the matter, times this latent heat coefficient will give us the heat transferred to or trans out between the material and the environmental. So, and for water, there are two phase change, right? So one is for ice melting. One is for ice melting to water, and the latent heat is given by coefficient 3.33 times 10 to the 5 joules per kilogram. And for the boiling is 2.26 times 10 to the 6. And this graph clearly shows the process for water. So first we have ice at negative 30 Celsius degree. We add heat to it, increase temperature to 0 Celsius degree, and then start melting. During the melting process, the temperature stays constant. And then we add heat to water. The temperature of the water will increase until it reaches boiling point, 100 Celsius degree. We keep adding heat. The water gradually becomes steam until all water becomes steam, and then we add more heat, the temperature of steam increases. So what here really means is that amount of matter changes phase is given by the energy added divided by this latent heat coefficient. So let's check out what are the energies required to change the temperature of this 1 gram of water. Let's see, my water is 1 gram. So it's actually 1/1000th of a kilogram. When the ice phase, we need to use the specified for ice. We increase the temperature of ice by 30 degrees here. So we need a 62.7 joules of energy to increase the temperature of the ice by 30 Celsius degree. We then increase. Now here, after we add 62.7 joules of energy, it's still ice at temperature 0 Celsius degree. So we need to melt all the ice to water by adding energy. And if we want to melt 1 gram of ice, we need to add mass times latent heat of ice. We need to add 333 joules of energy to melt ice to all water. So it will be 0 Celsius degree water right now. Okay. And then we need to increase the temperature of water. And the heat required to increase the temperature of water to 100 degree Celsius degree is mass times specific heat of water, which is different compared to specific heat of ice. And the temperature change is from 0 to 100 degree. That's how much energy we need. About 419 joules of energy to increase the temperature of water from 0 to 100. Now this part requires much more energy than all the process combined before. We need to change this 1 gram of water to all steam. So what do we need? We need to change 1 gram of water times latent heat for water becomes steam. So this is the water required to change all 1 gram of water from liquid phase to steam phase, and then we can increase the temperature of the steam. 1 gram of steam, specific heat of steam, increase the steam by 20 degrees, 40.2. Now here it requires much more energy because the latent heat for water to become steam is large, 2.26 times 10 to the 6 joule per kilogram. So go back to here, you can see it's almost the latent heat for water to become gas is almost 10 times now compared to the latent heat for ice to become water.